Okay, so now I'm back. So y is 2. Yes, so now we got y equals 2. All right. So now we have at least one of the points. So we know that here, this is... Oh, but we're still missing x, right? So now we got y equals 2. We can solve for x. Uh, Let me erase this. Let's erase this formula because as we're becoming experts, we don't need to write it. We just know it by heart. So, okay, so let's solve for 2. Okay, so how do we solve for that? Well, we know that, how do we solve for it? We can refer back to either one of our equations, and then we can just plug in y for 2. Let's do it for the first equation. I think it's a lot simpler. So the first equation said it's 16 equals, oops, sorry, it was actually because we isolated this, right? So let's plug it in. So x 16 minus 2. So what did that give us? 14. It's actually 12. Because 2 times 2, it's 4. 16 minus 4, it's 12. So now we can, we do have it. We have x as the square root of 2. So we got it. All of this hard work, we got the point. But, that was a lot of work that we had to do to solve for that, just that one point. But let me show you another way to do this. Okay? And let's see if we're right. So this is the answer. This is the solution. This is the vertex, the third vertex. But let me show you another way. So another way to approach this is that we have this equilateral triangle, right? Okay, we have it. And then we know that the distance is 4. Let me put it in here. Oh. So we know that it's 4 the all sides. So it's 4, 4, 4. Okay, but I can do something because I see something. I know that for an equilateral triangle, if I split in the middle, I know that the equilateral triangle, it's 60. They all have the same angle, 60, 60, 60, right? So if I split down in the middle, what do I get? I get this. I get 60, 30. These are the angles, sorry. And then 90, because we know that a triangle adds up to what? 100. So is this true? Yeah, it's 180. So we're allowed to do this. So we have this, so we can do this with the same equilateral triangle. If we split down the middle, what will this be? What will the distance from here to here? Remember, it's 0 to 0, but we know that it's 0 to 4. Well, the midpoint will just be 0 to 2, right? So it'll be 0 to 2. So now, instead of looking at this equilateral triangle, we actually have a right triangle. Let me use another, I use this, a blue one. So we actually have this, okay? So we actually have this, and it's 0, 0, and then 0 to 2. But how does this help us? Well, we know that this side is still 4, and this side is now 2. Oh, what do we see? We see a right triangle, and then we can use the Pythagorean theorem to find the other side. We can find this length here using Pythagorean theorem. So it's a squared plus b squared equals c squared. And we know that I would just say a is 2, or b could be 2, and then b squared, because we don't know what b is, that's b. And we know what c is, so it's c squared, and let's figure this out. 4 plus b squared equals 16, and then b squared equals 16 minus 4, which will give us 12, and then b is square root of 12. And this is the length of this, but that also means that the height of this right triangle is the square root of 12. So this point here is going to be, I should lower it down. So let's see, it's 0 and then 0. This is still 0. And then, it's going to be, is that right? Yeah. So here you go. That's the same answer as this one that we found earlier using the other approach.